All right, hello there. So today we're going to be talking about normal distribution and also what it has to do with probabilities. You will need a small calculator to do this lesson and to do the math space for it. Or you can use Desmos, and again, you can print out these pages if you want to beforehand, or just basically save the file or have the file open when you on your computer instead if you want to have it open while you're doing your math space so you can see some examples, if you don't want to print all this out. So remember some basic facts about normal distribution. You got 50% lies above the center and 50% lies below the center. So, you have 100% all together, and so 50 above, 50 below. It's symmetrical. Remember that this line right here in the center, that is your mean, your median, and your mode, because when something is said to be normally distributed, that's what has to be true. And remember these little marks here. This is 1 standard deviation above the middle. This is 2 standard deviations above. This is 3 above. This is 1 below, 2 below, and 3 below. And by the time you've covered 3 up and 3 down, you've basically almost covered 100% of your data. So that leads us to remembering the empirical rule here. So we're not going to use this that much today, or frankly at all, because what's going to happen is you're going to want to know like an area that, say, goes up to part way. So like, let's say 1.5 standard deviations, that's going to be your z-score. And so we're not quite sure what each of these parts would be worth, but there's a chart to tell us what it's worth. So just remember that if we want to go in between standard deviation marks, that's okay, but it's going to take a chart to tell us, and you could do it on a calculator or in Desmos as well, but we're just going to stick with calculating these from the chart that MathSpace gives us. So again, if you want it to be like between numbers or like, it doesn't always have to be halfway. Maybe you're like really close to -1, but not quite at -1. So you want to, know everything above that or whatever. So there's lots of situations. All right, so here's a chart what we're going to use. And what this chart does, notice there's no negatives on this chart, it's all positives. So what this does is this chart gives us the area under the curve, or basically the portion, because all of this adds up to 1. The area under this curve is 1. So these numbers in the chart here gives us the amount from the center out to where we stop. So let's say we stop at 1. So remember, that's our z-score. So if my z-score, if I stop at 1 right here, then I need to go look up on the chart. What I do is I go to 1, and that's 1.0. So do you see how it gives me right to this number right here, 34% or 0.34, right? Because that's, remember, that was half of 68. All right, so let's try a different one. Let's try z equals, let's say I want to stop at 2.5. Whoops, wrong one. Let's say I want to stop at 2.5. So that means that this chart is going to tell me the portion, or basically the probability of the space, the percentage of the space from 0 to 2.5. All right, so I would go to 2, and then over here is, oh, no, I'm sorry, 2.5 is right there. That's a different chart I'm thinking of. So 2.50 would be right there. So that would be the amount of space, or the amount that I would take from the center to that number. All right, so let's think about another one. And we'll be doing some examples that cover this. Let's say that I was going to, a z-score was -1.32. All right, so 1.32 would put me about right there, -1.32. So this chart, this is all symmetrical. 1.32 is the same as -1.32. So if I look up 1.3 and then the 2 right here, what I do is I go down and I wait till they meet up. So I'm looking at this number right here, 0.4066. So that means between these two lines, from 0 to -1.32, the amount of space in there, the area under the curve, is 0.4066. Okay, so that's basically it. Let's start some problems. So I'm just going to come back to this page every time I want a value from this. All right, so here we go. All right, so the table gives us an area between 0 and a given z-score. Using the table, find the area under the normal curve between the mean and 2 standard deviations above the mean. So what I'm doing here, I'm starting with the mean and I'm going up to 2. So I'm looking up for a z-score of 2 and I want to know how much space is covered. All right, so let's do it. So 2 is right here and then 2.0. So basically I'm looking for this number right there, 0.4773. So 0.4773 is my answer to this question. So some of your math space problems will be that simple. Example 2, using the table, find the area under the normal curve, and we want to go between the mean and 1.5 standard deviations below the mean. So that means I'm going to right here, from here to there. That's negative 1.5. All right, so I want to know what that space is right there. So remember, negative 1.5 is symmetrical to the positive 1.5. So I still look up the same thing. So 1.5, 1.5 is down here. I'm used to a different table that has it laid out differently. So 1.50 puts me to right there, 0.4332. So 0.4332. So if somebody was asking you to change that to a percent, you would say 43.32%. But on MathSpace, it's going to ask you for this number right here. All right. Using the table, find the area under the normal curve between 1.3 and 2.75. So 1.3 would be about here, 2.75 about here. So this is going to be a little bit trickier because we want to know that between these two things. All right. So remember that the whole thing is worth 50% or 0.50, okay? So let's see. Let's look up the further one first, 2.75. So 2.75, let me get rid of all this other stuff. So 2.75, so here's 2.7, here's my 5, so I'm going to go down to where they meet, right here, 0.497. So from the center to the farthest place is 0.497, all right? So let's check out from the center to this spot right here, which is the 1.3. All right, so 1.3 is right here, 0.4032. So 0.4032. So do you see, all I have to do is take these numbers, the blue one and the red one, and subtract. Because basically what's happening is I want this whole piece, but I don't want this part, and that's the red piece. So if I do 0.497 and take away 0.4032, that will be the part that I do want. So 0.497 minus 0.4032 gives me 0.0938. All right, so a little problem solving every once in a while. So this one, using the table, find the area under the curve between 1 standard deviations below the mean. So that's right here. And let's see, 2.25 above. So 2.25 would be about here. All right, so 1 below. So if I look up the number for 1, it's going to give me the space right in here from 0 to 1. So let's look that up. So 1 is right here, 3413. I know it's 34, but that was just kind of a rough estimate, so we're going to use 3413. So this piece right here is 0.3413. Now all I have to do is look up the space, and I will add them together. So that's 225. So 2.25, so here's 2.2. This blue line is my 5. So I'll be looking right there, 4878. So 0.4878. So we will just add those up. So 0.3413 plus 0.4878 gets me 0.8291. Okay? All right. So using the table, find the area under the curve to the left of 2.45. So 2.45 would be about here, and I want to know this piece over there. So remember, the chart gives me everything from 0 to the place I stop. So the chart is going to give me this. So, and I already know that this piece is worth 0.5. So what I'm going to do, since I have a little piece left over, you could do one of two ways. You could do 0.5 minus this little chunk right here, or maybe the easier thing for you to think of, that would probably actually be pretty easy, or we could think of it like this. The chart is going to give me this piece here, and that much is 0.5. So my whole probability, my whole chart, or my whole curve is worth 1. I'm just going to take away 0.5 and also take away that little piece I get from the chart. So 2.45 on my chart. So 2.45, so 2.4, and there's my 5. Let me erase that. And so there it is. 2.45 is 4929. 0.4929. All right, so 1 minus 0.5 and minus 0.4929. All right, so 0.0071. So either way you want to do it. All right, so number 6. Find the area under the curve to the right of 1.2. So 1.2. Oh my gosh, I just realized I did example 5 wrong. I'm sorry, I was thinking it backwards and I don't want to start my video all over again. So erase that. Oh, my mistake. This one said to the left of 2.45. Oh, I got my left and my right mixed up. So actually, I have the numbers that I need right here, 0.5 and 0.4929. So I actually have to add those together. So I get 0.9929. And this over here is just nonsense. All right, sorry about that. All right, using the table, find the area of the curve to the right of 1.2. All right, so 1.2. 1.2 would be about there, and I want this piece right here. Okay, so the easiest way to do this is to say to yourself that this whole side is worth 0.5, and if I look up on the chart how much this is worth, what I can do is do 0.5 minus that number, which will give me the red area. So I want 0.5 minus whatever the chart says for 1.2. So 1.2 right here, and there it is, 0.3849. 0.3849. So I just wanted to give you a lot of scenarios here to get you used to looking at the chart and reading it. All right, so I got a few more of these and then just some basic, like, overall examples. All right, so last one of these basic ones. Using the table, find the area under the curve to the right of negative 1.75. So negative 1.75 would be, about here, close to negative 2, and I want to the right. So what I want is I want all this space right over here. All right, so I know when I look up on the chart is going to give me from here to the center. And then I have to know in my own mind that this is worth 0.5 or 50%. So when I get them, I will just add them together. So negative 1.75, let's see. And this thing's getting too messy, so let's see. Now remember, negative 1.75 is the same as positive 1.75. It's just on the other side. So 1.75, so here's 1.7, here's my 5. So I'm going to come down across here. So there it is, 0.4599. So 0.4599. So add those up, I get 0.9599. And there we go. All right, so this area under the curve, what you are really finding, it represents the probability of a data value in your normal distribution lying within that range of numbers, okay? So remember that probabilities range from 0 to 1. 0 meaning it's never going to happen, and 1 meaning always, right? So probabilities can't go higher than 1. So the total probability is always equal to 1. All right, so we just have a couple more examples, I think. Yep, all right. So a couple more examples. The lengths of snakes in a certain jungle are normally distributed with a mean of 1.5 and a standard deviation of 0.2. So here in letter A, I've asked you to calculate the z-score for me. So in those last problems, you were given the z-score right off the bat. So here we have to calculate it. So remember the formula for the z-score is this. It's your data value minus the mean over the standard deviation. All right, so here we go. And remember, you can also see it like this, x minus mu over sigma. That's also a z-score, just different variables used for different situations. All right, so determine the z-score for 2 meters. So I'm going to do 2 minus 1.5, the mean, over 0.2. So 2 minus 1.5 is 0.5. So 0.5 over 0.2. Get your calculator, it comes out to 2.5. So on my z-score, I am right here. And the question B says, what's the probability that a snake in this jungle is less than, less than 2 meters long? So basically the probability is the stuff that we were calculating before and we just didn't know it. So less than 2 means I want everything to the left of my z-score. And I'm going to look up some things on the chart. I already know that this part is 0.5. So all I have to do is look up this part on my chart and add those together. So my z-score is 2.5, so let's look that up. So 2.5, there it is, 0.4938. All right, so let's see the probability that it's less than 2. That will add up to 0.9938. So it's just a different way the question is phrased. It's phrased in a sense of probability versus area under the curve. All right, so this next is my last example, but I just have a lot of pieces to it. So we're just going to deal with the same situation every time, same like situation, but different probabilities. So a company manufactures television sets. They claim that the lifetime is normally distributed, the lifetime of the set, you know how long it lasts, of 80 months. The mean is 80 months. And standard deviation is 8. Okay? So determine the z-score for 70 months. So my z is, I take my 70, my data value, minus 80, my mean, over my standard deviation is 8. So 70 minus 80 is negative 10 over 8, and 10 divided by 8 is 1.25, so negative 1.25. All right, so it always helps to draw a little picture. And so the question says, what's the probability that a TV from this company lasts shorter than 70 months? So 70 months was my z-score of negative 1.25. So it's about here. And I want shorter than this, less than that, so I need all of this. All right, so I'm going to have to do a little bit of thinking. If I want all that blue area, my chart is going to give me this part. But what I know is that the whole piece is worth 0.5. So if I take 0.5 and take away this question right here, that's going to get me the little blue part that I want. So 0.5 minus, let's go look up the z-score. Let's go look up the area for the z-score of negative 1.25. So negative 1.25. So here's 1.2. There's my 5, 39.44. So 0.3944. And it should be a really small answer, right? That blue area is really small. So it makes sense. 0.5 minus 0.3944, I get 0.1056. Okay. All right, determine the z-score for 60 months. So z equals 60 minus 80 over 8. All right, so again, it's below the mean, so it should be a negative z-score. So that's negative 20 over 8. So 20 divided by 8, I get negative 2.5. So negative 2.5, it puts me about right here. What's the probability that a TV from this company lasts longer than 60 months? So that means I need everything past it, to the right of it. So that's why you see greater than 60. All right, so my chart is going to give me from this spot to the middle. And then I know that this other part is worth 0.5. So I will just add those up. So I look at my z-score, negative 2.5. All right, so 2.5 is right here. I used it earlier, 0.4938. So this part's 0.4938. So I'm just going to add those up. So I get 0.9938. There we go. All right, my last example here. Determine the z-score for a TV lifetime of 85 months. So remember the 80 and 8 were the mean and standard deviation. So get 85 minus 80 over 8. So it gives me 5 over 8. So when you do 5 divided by 8, you get 0.625. So our chart only has 2 decimal places. So 0.625, I'm going to round that up to 0.63. Okay. So 0.63 puts me right to the right of 0, like, oops, maybe like right about there. What's the probability that a TV from this company lasts longer than 60 months? Oh, I meant 85. Sorry about that. Longer than 85 months. All right, so I want everything to the right of this, greater than it. Okay, so if I'm thinking about my chart will tell me this little portion right here. So what I want to do is take 0.5, the whole area, subtract the number I get from the chart, and that will give me the blue part that I want. So I'll be doing 0.5 minus whatever the chart tells me for 0.63. All right, so 0.63, let's see here. So 0.6, and there's my 3, so go over here, 2357. So 0.2357, 0.2357. So, it should be less than a half, so 0.5 minus 0.2357, and I get 0.2643. So this is the probability that the TV is going to last longer than 85 months. And, think about it, that's kind of a small probability. If something had a 26% chance of doing, or if something had a 26% chance, you'd be like, oh, that's not that good of a chance, but, that's what it is. And so the closer you are to 0, the worse your chances are. The closer you are to 1, the better your chances are. And that is it. I'll see you later.